So we're going to work on homework 7, this problem using reactant reaction order to predict changes in the initial rate. In this problem, we have 3 sets of data, and one of them includes a reaction rate and the other 2 do not. And our job is to figure out the rate of the other 2 reactions. So the first thing that we need to do with this problem is write a rate law from the information that is given to us in the words of the problem. It says that the reaction is second order in N2 and second order in H2. So that means our rate law is going to look like this. Rate equals K N2 to the 2 and H2 to the 2. And again, those exponents are coming from the problem telling us that it's second order and second order. And so we have our data set number 1. In our data set number 1, we know the rate, we know the concentration of N2 and also the concentration of N2 or H2. So we know almost everything about that problem. And then for the other 2 reactions, we know the concentrations, but we don't know the rate. So in this problem, what we're going to keep in mind is that the value of K, the rate constant, is going to be the same for the same reaction. For any given reaction, it's a constant. For any particular reaction. So if we can use the data for problem or reaction number 1, we can use the data for reaction number 1 to solve for K. Use reaction number 1 to solve for K. And then once we know K, we can use K and the concentrations to solve for the rate of the other 2 reactions. So let's start by figuring out what K is. For the first reaction, we know that the rate is 0.648, and I'm going to leave the units off just to save space because I don't have a lot of room here. And we know that that is K times the concentration of N2, which is, for reaction number 1, is 2.06. And don't forget that the problem tells us that's squared because it's second order. And then H2 is 2.30, and that also is going to be squared because it's second order. So now we're going to use our algebra to solve for the rate constant K for this reaction. 0.648 divided by 2.06 squared divided by 2.06 square, 2.30 squared. And we get a K of 0.02887. So now that we know the value of the rate constant, we will use K and the concentration of N2 and the concentration of H2 to solve for the rate for the reactions 2 and 3. So that will look, we won't have to do quite as much algebra with that. That will look like rate equals our K, which is 0.02887 times N2 for, we're solving for reaction number 2. So N2 is 2.06, and don't forget that's squared. And H2 is 0.282, and don't forget that is also squared. So that works out to be 2.06 squared times our rate constant times 0.282 squared. It looks like that rate is 0.00974. It wants 3 sig figs. Does that answer make sense? It's really slowed down. Let's look at our data going from 1 to 2. The concentration of N2 is staying the same, but the concentration of H2 is decreasing a lot, like almost by 1/10. So yeah, that really low number does make sense to me. So now let's do the same thing for reaction number 3. We're going to use rate law again. The value of the rate constant, 0.02887. For reaction 3, the value of N2, which is 0.379, don't forget that it needs to be squared, and the value of H2, which is 12.5, and don't forget that also needs to get squared. So that is 0.02887 times 0.379 squared times 12.5 squared. That we get a rate of 0.648. And that's the same as what we started with, 0.648 for this one and 0.00974 for this one. Now you might be saying, you might be able to see intuitively how to do this an easier or a faster way, and if you do, that's totally fine. There's definitely more than one way to solve this particular problem. But what I'm showing you here, this longer method, is a method that doesn't require you to intuitively understand how to solve the problem. This is just using straight math. So like I said, if you're doing it a different way and you're getting the same answer, if you're thinking in terms of like what's happening to N2 and what's happening to H2, so what would that mean in terms of how does the rate change? If you're solving the problem that way and you're getting the same answer, then you're doing it right.